So, this week in the Algebra 3, today, one example, and talking about your supplemental note sheet to make sure that it is 100% figured out, all that stuff, and possibly even rewritten once or twice or something like that. Great way to study this week is to rewrite your supplemental note sheet, your toolkit, your cheat sheet, whatever you're calling it. Okay? That is a great place to start studying for this week. Okay? Tomorrow, no class, but should be coming in, getting questions, all that fun stuff ready to go. Wednesday, we'll have a review type activity in class. Haven't decided yet what it's going to be. It might be an around the world. It might just be stations. It might be a quick solve type thing. Don't know yet. Haven't figured that part out. Debating that this afternoon. And then Thursday is going to be your test in class. Don't know how long it's going to be because I'm going through and I'm editing it. Might take a few questions off, might change around a few questions, might, do some crazy stuff like that. Maybe not make that long. Because remember, these are long for you, but they're twice as long for me because I've got to make sure you did everything right and you've got everything in the right position and all that fun stuff. So let's make it easier on all of us and maybe take a graph off. So you should have out your supplemental note sheet. That should definitely be out. And again, remember from day number 1, I said that this was going to be your note sheet for the final, correct? So I'm not saying that you can put other stuff on this other than what, we have what I told you to write down. But what I told you to write down was just the bare minimum. Okay? So if you need to write other things, jot some other notes on there to say, oh yeah, when the numerator is already factored in step 0, just use the factored one in step number 4 to find the x-intercepts. That kind of a thing. So, helpful little hints like that for you. Okay? All right. So let's talk supplemental note sheets going on here. So, step 0, simplify the function, right? Okay, how do we do that? Or what do we do in step 0? Greatest common factor first, then all of our other factoring type stuff. So we can lump that all together with just, we got that. Step number 1 then says, find the domain and vertical asymptotes. Domain, we'll take those in 2 separate parts here. Domain uses what? Which part of the original equation? That should be an n. That's a bad n. And what do we do with that original denominator? Equal to 0, solve it, all that fun stuff. Okay. After that, we use our new one if we have a new one, correct? Okay. So for vertical asymptotes, we would be then on new function. and then it's so usually the vertical asymptote was the restrictions in our domain, but one of them might have fallen out if we can't do something else. We simplify. Okay. Step 2, horizontal asymptotes. What do we do there? With the degrees. Okay. What are the 3? Big over small? None. But okay. Second one. What do you mean 0? And not divide the constants, no. Which coefficient? Lead coefficients. Y-intercept. Is that the function equal to 0? Those are 2 different things. You just told me 2 different things. That was the second one that you said.
Yeah.
Okay?
Yeah.
Yep. Okay? So we find f of 0?
Yeah.
Okay? How many y-intercepts can there be? 1. Okay? Can there be none? Yes or no? Yeah? When? When would I be dividing by 0? In which step would I not? Which step would tell me if I don't have a y-intercept? No? Which one? Because we got 3 of them. Vertical. If I have a vertical asymptote of x equals 0. If I have a vertical asymptote of x equals 0, I do not have a y-intercept. Otherwise, I've got a y-intercept. Okay? That's the only time that I won't have a y-intercept is if I have a vertical asymptote of x equals 0. That's fine. Because horizontals are different. Because horizontals are the value of the function. Verticals are what you put into the function. So like if we have a x equals 0 vertical asymptote, we can't put 0 into the function and get out a number.
Oh.
Okay. X-intercepts. Because the numerator equals 0. Because this was the first one that Raya was giving us, we want to set the function equal to 0, but then we would just when we cross multiply, it just ends up being the numerator. Equals 0. How many of these can we have? The degree of the numerator. The degree of the numerator tells you how many you're going to have. Okay? So when you're comparing degrees up in step number 2, you're also asking yourself how many x-intercepts I'm going to have in step number 4. Okay? Step number 5, find the whole. How do we find the whole? So if we factored something out in 0, then what? So we set whatever we crossed out in step 0, we set that equal to 0 into the new function, right? And that gives you the coordinates of your hole. How does that go on your graph? Big open dot, right? Big, I shouldn't say big circle. Small circle at that coordinate. Okay. Should you draw right through your circle? No. Pick up at the circle. Go to the other side. Keep on going. Okay. Step 6. Find the slant asymptote. How do we find the slant asymptote? Do the division. Hopefully, we'll be able to do the division synthetically. From last unit, from unit 3, which I know was a while ago, what kind of divisors can I do synthetic division with? If I want to do the division, I've got a dividend and a divisor. Dividend is what's being divided into. The divisor is what's going to be divided, what you're dividing by. What must my divisor look like? You're one step ahead. You're in step 2 of synthetic division. Before I can even synthetically divide, what's it got to look like? Now I see why people tried to synthetically divide by x squared minus 1. Number 1 on the quiz last week. Way too many people tried to do that one synthetically. And the divisor was x squared minus 1. Can I do that? Why not? Because it's squared, right? What's the only way I can divide a squared? Long division. Okay? So what's my divisor gotta look like in order to do synthetic division? got to be linear. It's got to be a linear factor. Can't be a square, can't be a cube. Gotta be linear. Okay? So 1x plus 4 could be synthetically divided. Okay? So we have to do that. And you have to have that. If you don't have that, you've got to do long division. Okay? And then lastly, we just find any additional key points. Okay? All right? Let's do it. Go for it. Step 0 says that I need to factor the top. Can the top be factored? Okay, so we've got x minus 1, and then we've got x plus 2 and x plus 1. Okay? On the bottom, we've got, can the bottom be factored? What? Anything cancel out. My x plus 2's cancel each other out. Okay? So my new function going forward, actually I shouldn't say that. My new function will be f of x equals x minus 1 times x plus 1 all over x minus 2. Yes? All right. So the domain of my function. All real numbers, but x cannot be plus or minus 2, because it can't be from my original one, so it can't be x plus 2 can't be 0, so that would give me the negative 2. X minus 2 can't be 0, so that would give me the positive 2. I would agree with plus or minus 2 there. For everything after that now, what do I use? I use my new function for everything after that. Now, I have the luxury of being able to scroll down. Okay? You might just have to put your hand over the top of it. Okay? All right? So, what is my vertical asymptotes now? X equals 2. My horizontal asymptote. None, because what's the degree up top? 2, because there's 2 x's. Another way to find degree is we count the number of x's there are. Okay? 2, bottom, 1. 2 over 1 is big over small. That's a none case. But it differs by 1. Okay? Y-intercept comes next. 0, comma. 0 minus 1 is negative 1. 0 plus 1 is positive 1. Negative 1 times positive 1 is negative 1. 0 minus 2 is negative 2. Negative 1 divided by negative 2 is 1/2. X-intercepts is next. How do I find the x-intercepts again? Numerator equal to 0. So that would be x minus 1 equals 0. So that would be 1, comma 0. And x plus 1 equals 0. So that would be negative 1, comma 0. Step 5 would be holes. Did I factor anything out way from the start? I factored out an x plus 2, right? So I've got to set that equal to 0. And I get x equals negative 2. Then what I need to do is I need to find f of negative 2. Well, that's going to be negative 2 minus 1 is negative 3. Negative 2 plus 1 is negative 1. Negative 2 minus 2 is negative 4. So that would be at negative 3/4. Slant asymptote is next. So first off, I take my denominator and I set it equal to 0. Solve it. That gives me my outside number. Inside numbers are the coefficients. Well, it's in factored form, so what I have to do first is I have to do the multiplication. Now I can say it's 1, 0, and negative 1. X minus 1 times x plus 1 is x squared minus 1. So it's 1x squared plus 0x minus 1. Drop the 1, multiply, add, multiply, add. Drop the remainder. So my slant asymptote then becomes y equals x plus 2. In my left zone, it can either be my function, either has to be down here, or it has to be up here. Is it on top or bottom in the left zone? On the bottom, because we have all 4 points there in that left zone. So that's where my function is going to be. No need to find more points. Remember, when you're graphing, your function will always end up along an asymptote. Okay? Right zone. Don't have any points over there, so we have to figure out what some of these points might be. So let's go with 3. If I plug 3 into my function, 3 squared is 9, minus 1 is 8. Over 3 minus 2 is 1, so that's 8. 2, 4, 6, 1, 2, 3, 5, 6, 7, 8. There it is. Okay. That's enough to tell me, and by now that should be enough to tell you that that function is up there. If not, find more points. Okay. If I plug in 4, I should get 7 halves, or excuse me, 7 and a half. If I plug in 5, I should get 8. And so on. Okay? When you came in today, you should have picked up the yellow homework packet. That is your Chapter 4 review packet. It will be due on Thursday of this week, since we don't have school on Friday. Okay? And Thursday will also be your summative test for this unit. You will get to use your supplemental sheet on the unit. And like I said at the beginning of class, the best way to study these is to make a better supplemental sheet. Okay? The more times you write this stuff down, the more times you'll understand what you need to do at in those particular steps.